Bismillahirrahmanirrahim. Assalamu alaikum. Today we will start with section 2.5, continuity of functions. Here we have a definition at interior points of the domain. A function y equals f of x is continuous at an interior point c of its domain if the limit of the function as x goes to c equals the value of the function. So lem f of x as x goes to c equals f of c. At the endpoints of the domain, a function y equals f of x is continuous at the left endpoint A or is continuous at the right endpoint B of its domain if limit f of x as x goes to A from right side equals f of A or limit f of x as x goes to B from left side equals f of B respectively. There's a test we use it's called continuity test with the 3 steps. So a function f of x is continuous at an interior point x equals c of its domain if and only if it meets the following 3 conditions. Condition number 1, f of c exists where c lies in the domain of f. Limit f of x as x goes to c exists. F has a limit as x goes to c. Limit f of x as x goes to c equals f of c. The limit equals the function value. So these 3 conditions have to be met in order for the function to be continuous. If one of these 3 conditions is not satisfied or is not met, then we will say the function is discontinuous. Let's understand the continuity of this function. We have here a graph of this function. We have seen this function in the previous section where we found the 2-sided limits of the function. And we want to find here for this function, we want to test the continuity in the domain from 0 to 4. So here 0 is called the left end of the domain, 4 is the right end of the domain, and all the points between 0 and 4 are called interior points of the domain. So we want to test the continuity of this function at x equals 1, at x equals 2, and at x equals 4. Now, the points where the function is continuous from the graph here, you can see at x equals 0, the function is continuous from right because it's an endpoint, it's the left endpoint. At x equals 3, the function is continuous. Okay, so and for any point, any interior point between 0 and 4, the function is continuous except at x equals 1 and at x equals 2. You can see the graph. If the graph is broken, means like here at x equals 1, the graph is broken, means the function is discontinuous, not continuous. At x equals 3, the graph is not broken. How about at x equals 2? The graph is broken, there is an open circle. And how about at x equals 4? You can see here at x equals 4, the function is not continuous. Okay, we'll say the function is not continuous from right because this is the right end. Okay, the points where the function is continuous, you can see here, or the function is not continuous at 1, at 2, and at 4. Okay. For any value of x less than 0 or greater than 4, the points are not in the domain of the function, so we cannot say the function is continuous because there is no function. Okay, so let me show the steps of solving these kind of equations. Like a point, I will choose point 1, and I will choose point 3, and maybe I'll choose point 0 as well. So let me start at x equals 1. So to test the continuity of this function, first we have to find the limit of the function at x equals 1. So we have to find first the 2-sided limits. So we will say lem f of x as x goes to 1 from left side is equivalent to 0, because when we approach x from the left side, we are following this line, okay, for values less than 1, for values of x less than 1. So as x is approaching 1 from the left side, the value of y is going to 0. How about the right side limit? Lim f of x as x goes to 1 from right side is equivalent. See, right side means we are interested in the region that is greater than 1. Which is this horizontal line. So the graph of the function follows the horizontal line here. So as we approach x equals to 1 from right side, the value of y is 1. So you can see here the two side limits are not equivalent. So we will say lim f of x as x goes to 1 equals to d and e, simply because these two limits are not the same, So they are different. So the limit of f of x as x goes to 1 does not exist. So since this condition, this is the first condition of the test. So since this condition is not satisfied, then we will say f of x is not continuous. So we'll say f of x is discontinuous at x equals 1. And from the graph, it's very clear that the graph is broken at x equals 1. Okay? Now let's see another point, point 3. Again, we have to apply the three conditions of the test. The first one is to find the two-sided limits. So lim f of x as x goes to 3 from the left side. Means we are interested in this region, so the graph of the function for values of x less than 3 follows this straight line. So as x is approaching 3 from left side, the y is going to 2. So the y value is equivalent to 2. Now for lim f of x as x goes to 3 from right side equals to also 2, because we are talking about this line. So as x is approaching 3 from right side, the value of y is going to 2. See, the two-sided limits here, the same. They are the same values. They are equivalent. Hence, lim f of x as x goes to 3 is equivalent also to 2, because the two-sided limits are equivalent to 2. So the first condition is met. So the second condition is the value of the function. What is the value of the function at 3? So f of 3. From the graph here, when x equals 3, y is equivalent to 2, because there's closed circle here. So this is 3. This is 2. So at x equals 3, f of 3 or y equals to 2. See, from condition 1, the limit is equivalent to 2. From condition 2, the value of the function is equivalent to 2. And hence, because they are same, we can say the function is continuous. We can write here, we can say since lim f of x as x goes to 3 equals lim equals f of 3, not lim, equals f of 3, then which is 2, then f of x is continuous. F of x is continuous at x equals to 3. So at x equals 3, the function is continuous, and from the graph we can see that the graph is not broken. Okay. Now for the left end, for the left end at x equals 0, you can see here the left side limit of the function does not exist because the function is not defined for x less than 0. But the function is defined for values greater than 0. So we are interested about the right side limit. So the right side limit here, we can say, let me write here, lim f of x as x goes to 0 from right side equals to 1. Because as you approach x from right, you have to follow this line. So when x is very close to 0, the value of the function is very close to 1. So this is the limit of the function from the right side of 0. How about the value of the function? So this is the first condition. The second condition is f of 0. F of 0 is equivalent to 1 also, because the value of the function is 1, there's a closed circle. Since both the limit and the value of function they are equivalent, so we'll say here lim f of x as x goes to 0 from right side equals f of 0, which is 1. Okay. Then the third condition is satisfied. We will say f of x is continuous. F of x is continuous from left at the left end, from left at x equals 0. Okay. Now for 4.2. For point 2, you can see here, you can do this at home, but I'll give you the answer here. The limit from left side is 1, the limit from right side is 1, so the limit of the function here is 1. However, the value of the function is 2, so the third condition is not satisfied. The limit is equivalent to 1 and the value of the function is equivalent to 2, then the function is discontinuous because condition number 3 is not met here. And you can see in the graph here there is open circle. Open circle means the graph is broken. For the other endpoint to the right here, you can see the limit of the function is 1. As you are approaching 4 from left side, the limit of the function is 1. The value of the function is not 1. It's here, somewhere like 0.5. It's different from the limit, the left side limit at x equals 4. So the limit, the left side limit of the function is 1. The value of the function is not 1, is 0.5. So the limit does not equal the value of the function, hence the function is discontinuous. There's no right side continuity. So the function is discontinuous. So this something about the continuity of the function. In the next video, we will discuss the solution of some questions graphically as well as analytically. Okay? So I will stop here and I will see you during the class, inshallah. Assalamu alaikum. Bye bye.